Hello, everybody. Our group is looking at Facebook metrics data. Our group has Ashish, myself, Ben, there's Joe, and Bharat. Our data structure has 19 variables, 500 observations, and 4 missing values. This is a plot of all the histograms of all of the numerical variables. Looking at how most of the variables are skewed to the right, we decided to do a log transformation, except for the variable PTL. This is the distribution of the histograms after it's been log transformed. As you can see, most of it are more normally distributed now. We also have 2 categorical variables, which are type and category, 3 ordinal variables, which are post month, post week, post hour, and 1 binary variable, whether or not the post was paid. Here is a correlation plot of the numerical variables. And I will pass on for Ashish to begin discussing regression.
So my variable of interest is page total likes. On the next slide, I performed all subset selection. The best model to use consisted of 4 variables, which had an R-square of about 41%. On the next slide, I performed ridge regression, which gave me an RMSE of 12926.98 and an R-square of 32%. On the next slide, I performed lasso regression, which gave me an R-square of about 31%. And on the next, I performed elastic net, which gave me an R-square of about 36%. And finally, I performed relaxed lasso, which gave me an R-square of about 37%. So here is my table, which summarizes the data. For future, I will be doing RMSE of relaxed lasso and be looking into multicollinearity and overfitting.
My variable of interest was total interactions, which is the total of comments plus likes plus shares. And I started with an all subset regression, and you can see that I can get an R squared of 81% using only 3 variables, or I could sacrifice just a little bit of that explanatory power and get a model using only 2 variables and get an R squared of 80%, which is really good. I also tried it with Bayesian condition and got the same model, same results. So next I did ridge regression, and these are just some preliminary graphs showing the range of lambdas. On the next slide, I did the cross-validated version, and the result was an R squared of 64.8 and an RMSE of 0.7316. Next, I did the lasso regression, and again, this is just a preliminary slide showing the lambdas. And then I did the cross-validated version again, and the prediction calculated the RMSE of 0.5639 and an R squared of 81.6. Last, I did the elastic net, and again, this is a preliminary slide showing the range of lambdas. And next, I did the cross-validated GLM net and got a result of RMSE equals 0.5653 and an R squared of 81.6. So when you look at all the results, basically learned that lasso performed the best. It had the highest R squared and the lowest RMSE. And by the way, there's no overfitting either. Going forward, I'm going to look into doing the relaxed lasso and add that to the analysis.
I did principal factor analysis and common factor analysis on our data set. Yeah, before doing factor analysis, we have to clean the factors. For cleaning factors, I did code test. From the above results, we can see that variables LPC and LPC have a value as 12, which means that it is correlated with all the other variables. So we have to remove these variables while doing factor analysis. This is the tree plot which we got after doing principal component analysis on this data. From this tree plot, we can see by using Neon variance rule, the number of factors could be 3 or 4. Next slide, please. Yeah. To determine the number of factors, I have done factor analysis. From this factor analysis, we found that number of factors as 3. Next slide, please. Yeah, this is the summary of results of principal factor analysis and common factor analysis. In principal factor analysis and common factor analysis, the results are almost similar, but the distribution of variance among the variables is categorized in common factor analysis, whereas in case of PFA, we are not able to categorize these variables among these factors. Next slide, please. Yeah, these are the inference of common factor analysis. We can say that factor 1 consists of variables, which explains about the actions which are done on the pages, such as like, comment, and share. Factor 2 consists of variables which discuss about the number of clicks on a page and the number of pages on the number of posts on a page. Factor 3 comments. So factor 3 discuss about the variables which explains about page post total impressions. Factor 4 component discuss about the variables which explains about total post reach and on the page.
I conducted a correspondence analysis that looked at the post type and the post category. For the post type, if you see on the top left, when it's status, it likely corresponds with product and unlikely corresponds with action and inspiration. On the top right, the figure shows the correspondence for photo, and it is likely corresponds with inspiration followed by action and unlikely with product. Then the bottom two are shown for video and link. And these are very similar in the fact that they both are likely corresponds with action and unlikely with inspiration and product. Then for our third main lines of analyses, we did a cluster analysis. Our process is that we first did a multidimensional scaling where we constructed the ISO MSD plot and diagnosed the goodness of fit using stress and the Shepherd diagram. Then using a density-based clustering where we're able to use the best combination at EPS equals 1850 and min points at 21, and followed by putting these assigned clusters back into the original data and remove the outliers. We ran an LDA to determine if the clusters can be separated and interpret the combination of original variables that were useful for the separation. So for multidimensional scaling, our stress was 0.0004, which I like to remind that anything less than 0.1 is excellent. Then the bottom diagram shows the Shepherd diagram, which as a straight line, which another indicator that the separation is good. Then the plot on the right is the ISO MDS plot. As you can see, about at coordinate around -1,000, there's a big cluster. At around 0, there's another cluster. Around 1,000, there's a bit of a cluster, and about 30,000, there's also another cluster. So using density-based clustering, there are about 5 clusters and 62 outliers using the parameters that we tested in trial. Then putting back into a linear discriminant analysis, we found that the proportion of trace for LD1 was actually 97.26. So just with one component, it was able to separate out the clusters with very little amount of misclassification, only for 5 data points out of what we have. Then looking at a histogram of the first linear discriminant component, we see that it separates out the first 4 clusters really well, and the only issue is between 4 and 5, and that kind of is reflected on the confusion matrix previously. Then looking at the interpretation of the first linear discriminant analyses, in the negative side, we have lifetime post reach by people who like your page, lifetime post consumers, and lifetime post total impressions. And on the positive side, we have a lifetime people liked your page and engaged with your post, lifetime engaged users, lifetime post impressions by people who have liked your page. So it's a dichotomous scale, but without more domain knowledge, it is very difficult to interpret what they could mean. So we will now go into our discussion.
Discussing the predicting the post total likes, relaxed lasso was the best technique to get, which produced the best R-squared value. The variables used for modeling was lifetime post total impressions, lifetime post consumers, lifetime post impressions by people who have liked your page, and lifetime people who have liked your page and engaged with the post.
And for predicting total interactions, we learned that most of the variability was explained by two variables, the log of lifetime engaged users and the log of lifetime post consumers. There was an R-squared of 80% using these two variables. And for the regularized regression, Lasso performed the best. It had the highest R-squared, the lowest RMSE, and there was no overfitting.
Yeah, the practical implications of principal factor analysis and common factor analysis are, it helps to extract the latent factors from the data, and it also helps to reduce the multicollinearity in the data. This analysis will help to group the variables into factors, and it also helps to find the relationship among the variables based on their variance values.
Then for correspondence analyses, we discovered that when a status post are more corresponds with product, a photo post is more corresponds with inspiration than action, and then a video or link post is more corresponds with an action. Then with our clustering analysis, we found that there were 5 clusters that are significantly different within our data set, but we do need more domain knowledge to try to help to gain more understanding. But some of the practical implication is that we can use this information to make more inferences about other posts. Thank you for everybody for listening, and we appreciate any feedback.